In this video, I'm going to be introducing the chain rule, which is how we find the derivative of a composite function. So the first thing we need to do is recognize what a composite function is. So a composite function is essentially a function inside of another function. So in these first couple of examples, we want to take a composite function and break it down into an outside and inside function. So in this definition right here, g of x is my inside function and f of x is the outside function. So y is equal to f of g of x means that g of x is within the function f of x. See, if you put a little box around it, g of x is inside f of x. So in this first example, what's inside the parentheses here would be my inside function. So the inside function is x plus 2. The outside function would be what we obtained if we simply wrote this with nothing in the parentheses, and then we just put an x in there. So x cubed would be the outside function f of x. In the next example, which is an exponential function, the exponent will always be the inside function. So 3x minus 4 is going to be the inside function, g of x, and then the outside function is going to be e to the x. And in the third example, the inside function in this radical, what is underneath the radical sign will always be the inside function. So we have, in this case, g of x is equal to x squared plus 3 is the inside function. And then the outside function is the square root sign. And so we can say that the outside function, f of x, is equal to the square root of x outside. And so the most important thing here is to just recognize when you have a function inside of another function. So what we really are interested in doing is knowing how to find the derivative of a composite function. And so there's a nifty little formula here. If you have a function which is written in the form y is equal to f of g of x, if it's written in this form, where g is the inside function and f is the outside function, then the derivative of that can be found by finding f prime of u times u prime. Now, I haven't exactly explained in this video what f of u and u is, because I'm going to show you a kind of a shortcut method for finding the derivative using the chain rule. And so I'll demonstrate that with this first example. So we want to find the derivative of y equals 3x plus 2 squared. So what I really want you to be able to do is recognize that this is a composite function. 3x plus 2 is the inside function, and x cubed is the outside function. So what we do is we start, when we have a quantity in parentheses raised to a power, we're going to use the power rule. We're going to take the exponent and we're going to bring it down just like we would with the power rule. Y prime is bring the 2 down in front. So we have 2. Then write what is in the parentheses, the inside function, and then reduce this power by 1. So that would be just to the first power. And now here's the chain rule part. Remember, this is my inside function, right? The 3x plus 2. We now take the derivative of what's in the parentheses, that is the inside function. And the derivative of 3x plus 2 is just 3. And that is the derivative. But of course, as always, we're going to clean it up a little bit. So what I can do is I can multiply this 2 times the 3 to get 6 times 3x plus 2, which is just to the first. And so that then becomes 18x plus 12. There's my derivative. Let's try that with this next one. So recognize that we have a composite function. We have the inside function right here, 4x squared plus 2x minus 1. And then x cubed is the outside function. And so we're going to bring the exponent 3 down in front. So y prime is 3, just like using the power rule, bring the 3 down in front, times what's in the parentheses. And then we reduce that power by 1, so now it's squared. Now this is the part everybody forgets. Do not forget, we now take the derivative of what's inside the parentheses, that is the inside function. So the derivative of 4x squared is 8x, and the derivative of 2x is 2. This is what makes it the chain rule. It's kind of like a chain, whereas this is the first link in the chain, this is the second link in the chain, and then this little part over here is the third link in the chain, and all these links are being multiplied. Multiplied by this, by this, by this. It's a chain. Now we can clean this up as well. So multiplying the 3 by the 8x plus 2, we would have 24x. 3 times 2 is 6. Now we can multiply times x squared plus 2 because it's just to the first power. We can't multiply to what's in the parentheses here because it's being raised to the second power. We would have to square that first. So I'll just write it as it is. All right, next example. The inside function is the exponent. Remember, with an exponential, the inside function is always the exponent. So remember how we find the derivative of an exponential. The derivative, if y is equal to e to the x, then y prime is equal to e to the x. So we're going to use this general rule. So we have y prime is equal to itself. So it's times e to the 3x squared plus 2. Just like the derivative of e to the x is e to the x, the derivative of e to the 3x squared plus 2 is e to 3x squared plus 2. But now we have to apply the chain rule. We now tack on at the end the derivative of the inside function, 3x squared plus 2. Okay, we have to take the derivative of that, which is 6x. And that would be your derivative. In this case, that's all you have to do, although sometimes it's a little bit cleaner to put this out in front and put the exponential at the end, but it makes no difference really to the answer. We now have a radical. And so with a radical, remember that the inside function is underneath the radical sign. And so when we want to take the derivative of a something underneath the radical sign, remember what we did when we had the square root of x, y prime, we would rewrite this as x to the 1/2 power, right? And then we would have 1/2 x to the negative 1/2. Well, we're going to do the same thing here. Y is really the inside function raised to the 1/2 power. Now we can apply the power rule. Bring the 1/2 down in front, times the x squared plus 3 to the 1/2 minus 1 or negative 1/2. And now the chain rule part. This is the chain rule. We have to take the derivative of the inside function, which is 2x. Or in other words, the derivative of this. And so we can multiply this times this to get 1/2 times 2 is 1. X times x squared plus 3 to the negative 1/2. And I don't want to leave that like that, so I'm going to rewrite this as x over the square root of x squared plus 3. And there is my derivative. Okay. In this particular problem, we have 1 over x squared plus 2. In this particular problem, because we have a quotient, let's let u, the inside function, be equal to x squared plus 2. All right? And what I want to do is I want to rewrite this as 1 over u. So this is a little bit different. I'm going to write this as y is equal to 1 over u. And since I want to bring the u up to the numerator, I'm going to make that u to the negative 1. So in other words, I could just say that this is y is equal to x squared plus 2x, all raised to the negative 1 power. All right? So this is my u. U is this part of that. And so we bring it up to the numerator and raise it to the negative 1 power, because this is really raised to the first power in the denominator. Okay, well now we apply the chain rule and the power rule. So we bring the negative 1 down in front, times the x squared plus 2x, and then we subtract 1 from that to get negative 2. And then the chain rule part, we take the derivative of the inside function x squared plus 2x, which is 2x plus 2. So what can we do to clean this up? Well, we can take the negative 1, multiply it through by this, and then we can take this, which is raised to the negative 2 power, and put it in the denominator raised to the positive 2 power. So negative 1 times 2x minus 2 is negative 2x minus 2. And then all of this comes down to the denominator raised to the positive 2 power. And we'll do one more in this video. In this case, we have inside function is 5x squared minus 3x plus 2. So we're going to apply the power rule. We're going to bring the 3 halves down in front. So y is equal to 3 halves times the inside function to the 3 halves minus 2 halves, or 1/2 power. And then the chain rule part is the derivative of what's in the parentheses, or the inside function, which would be 10x minus 3. And now we could clean that up a little bit by multiplying the 3 halves times this. So 3 halves times 10, 10 divides by 2 is 5, times 3 is 15. So we have 15x. 3 halves times the minus 3 would be minus 9 halves. And then all of this, oh, I don't really need that. I'm going to write a square root side. And so that becomes 5x squared minus 3x plus 2. All right, so that is the chain rule.